Welcome to class, students. Today we're going to be talking about frictions and flying balls. So there are three things I want to mention, and I mentioned it earlier in the lesson, which was elevations. The next one is angle, and the last one is speed. So when it comes to elevations in this simulations, we have elevations. The lowest elevations, it's 55 elevations, and the highest elevations will go up to 14,109. That would be the highest elevations. And the angle, the lowest angle, it's 0. And then the highest angle it go up to would be a 90-degree angle. So the speed, the lowest speed you can hit the ball at would be, I want to say 10 miles an hour. That would be the lowest speed. And the highest speed, it goes up to 135. That's the highest speed. So today we're going to be talking about elevations, angle, and speed. So if I go ahead and start with the first one, which is New York, which have the very lowest elevations, and I want to keep the angle at a 45-degree angle, and I want to keep the speed as high as possible, which is 135, and I hit 8. This is pretty good. So this is 412 feet. Let's go ahead and give it a try. So this right here is the clear. So if I want to clear my screen, I go and hit this. It clears the screen. So I'll go ahead and start over. So my elevation is 55. My angle is 45. My speed is 135. So when I hit the hit, so I hit the ball about 412 feet, which is a pretty good hit. This can be a home run. But if I change the elevation and just go down to Toronto and keep the same speeds, keep the same angle, and see what happened. So it's pretty much the same thing. So I start to go down into the higher elevation, which with this one, and I keep, remember, I always keep in the same angle, and I'm just changing elevations. I keep in the same speed, and I'm changing the elevations. So the elevation change, first it was at St. Louis, which was 400. Which the first one was at Toronto, which was 247. And now I would change the elevation to St. Louis, which would be 470. And they gave me the same height, 415 feet. So if I change the elevation, because the higher I go into Milwaukee, which is 593, again, I'm always keeping the same angle. I keep the same speed. Now you can change any of these to your liking. For example, I can change the speed, I can keep the same elevation. I can change the angle, I can change the speed, and I can have a different elevation. So now I go, so if I'm a pitcher, one thing I want to keep in mind would be to play at a very high elevations with the angle, a 45-degree angle with the highest speed possible. But let's say in the case that if we go to Kansas City, which have an elevation of 755 with the same angle, so the ball travel a lot faster. But if I go ahead and go to the highest elevations and with the same angle, so it's even harder. So with the higher elevations, the ball spends a lot of time in the air. So if I'm a hitter, this is where I want to play because I know our 4,109 elevation at the 45-degree angle with the highest speed possible, which was 135, there is no way anyone can catch my ball because I can easily get a home run every time I hit the ball at that speed, at that angle. So this would be a good play for a hitter to play. But what if I was a pitcher, this would not be a good place for me. This would be somewhere that I don't want to pitch and I don't want to play it because the chance of me, for someone getting a home run, it's pretty possible at this elevation. So what if I go ahead and change the speed to let's say 25, and change the angle, which is 25-degree angle, and change the speed to hundreds. So at the higher elevation, what would that be? So now this seems a little reasonable. This can give me options of really, as a pitcher, going back and trying to catch the ball. If I move to a lower elevations with the same speed and the same angle, so I'll go ahead and clear the first one. This is clear. So I hit. Okay. So now, as a pitcher, New York might be a good place to play. It might be a very good place to play because of the same angle and the same speed. I might be able to catch the ball. But what if I increase the angle and I say, this is for the pitcher. I want to go ahead and increase the angle to a 45-degree angle and hit clear to start all over. Now, this gives me options. With the lower elevation, the ball doesn't spend a lot of time in the air, so I can easily catch the ball as a pitcher. But if I increase the elevations, keep the same angle at the 45-degree angle with the speed 100, the ball even spend more time in the air. But what if I increase the angle to, let's say, 60-degree angle and hit clear and start over? So now at the 60-degree angle, this is where I want to play as a pitcher. It gave me a lot of opportunity to catch this ball because it spent a lot of time in the air before coming down. But if I reduce the angle, so the higher the angle is, the better it is as a pitcher. And the lower the angle, the better it is as a hitter. So if I reduce the angle to 10 degree and at the higher elevation, and I hit clear to start all over to give you a better view, now this becomes very tricky. You cannot catch this, but it's not going too far with the lower elevation. But if I increase the angle to 35, okay, this is more reasonable. As a hitter, I want to probably go at the higher elevations with the 35-degree angle with the same speed. Now, there are a few things I want you to think about. Where else can we use this scenario? If I live, for example, if I'm a track runner and I run track, I think it would be better if I live in places like, for example, like New York, that have the elevations of, let's say, 55 elevations, which is a lot lower compared to places like Denver, which is 5,183. I want to make sure I have proper training before running in Denver because it will be hard for me to run in Denver compared to New York with the lower elevation. But if I live in places like Denver, vice versa, it will be hard for me to run in New York with the lower elevations if I'm coming from a place that I used to run it in the very high elevations. So I think as a runner, as a track star, you have to understand the important elevation, the importance of elevation when you are a track star. If you are running track, angle doesn't really play that much, doesn't really factor that much into running track, but elevations play a huge part because this also play a huge part on your lungs to see how long it takes to breathe and how long you got to catch in air. So elevation play a huge part when it comes to running track or just running. And let's say for it comes to, so people who live close to the sea, they have a different elevation compared to people who live in a city that is not close to the sea. So what I would need for my class to do would be for you to come up with 3 real life scenario, and 2 of them doesn't have to be about baseball. 2 of them should be about something. For example, I mentioned track, Uh, the other one could be about real life example. For example, another example I could also use in this scenario could be now if I live in the places with the high elevations. Now, is it very hard to drive in places with high elevation? Am I going to be burning a lot of gas if I drive in places that have a high elevations compared to places that have a lower elevation? Or if I'm not burning gas, do I have to step on the pedal a lot harder to go compared to if I'm living in places with a lower elevation? So this is something you can also think about and see if you can find more information on this to say, living in higher elevations, you burn more gas compared to living in lower elevations. Or you could also say, if you live in higher elevations, you have to step on the pedal a lot often for the car to move because of the higher elevation compared to living in places with a lower elevation. So this is something you can also think about. So for this class lesson, I hope you understand my point of elevation, speed, and angle. You should come up with three example. One of them should be about baseball or about sports, and then the other two should be about a real life experience. So I would just go back and review what I mentioned earlier, that the main topic was elevations, angle, speed. And the button over here is something, for example, if I want to increase the angle, I hit the plus sign. If I want to decrease the angle, I hit the minus sign. It's the same thing with speed. If I want to decrease the speed, so I hit the minus. If I want to increase the speed, I hit the plus. So if I hit a couple of runs, and let's say, for example, I hit the ball and I go after it landed, and I changed the elevation to Atlanta, and I changed the speed quick, and I hit the ball again. So now if I want to clear everything out, I just hit clear it. So it clears everything out, then I can start over. It gives me a better uh, a place to play, a better way to record my standing. So I think if I want to get a home run, I want to get a speed of, if I want to hit the ball out of the park, if I hit, uh, uh, so if I want to hit the ball out of the ballpark at the high elevation, I have to have an angle of 35-degree angle and the speed of 135. So with the low elevation, what happens if I receive the same speed and same angle? So I hit about 422 compared to the first round, which was 578. So there's a big difference. So I hope you understand this lesson, and please ask any question that you may have that I can answer. So remember, we talk about elevations, we talk about angle, and we talk about speed, and I also ask you, how can you use those three things, of speed or angle, which one that you can use in your real life? And I need you to come up with three examples that you can explain based on this lesson, that you can compare to this lesson using angle, speed, and elevation. Thank you. I hope this was helpful. Please ask me any questions if you need to. Thank you. Have a nice weekend.